For this example, we want to find all of the zeros of x cubed plus x squared minus 5x minus 2. And for this, we could jump straight to the cubic formula. The cubic formula works. The cubic formula is valid. It's good. It's not very nice, though. So instead, we're going to do something that's arguably less productive. What we're going to do is try and identify all of our pieces here where we know that by the rational zero theorem, by the rational root theorem, these have to match up nicely along the leading coefficient, 1, and the constant coefficient, -2, which means that our zeros will have the form plus or minus 1, plus or minus 2, if they happen to be rational. The reason why this isn't always so great is because, well, you can sometimes get a lot of terms, and you're not guaranteed that any of them are particularly good. For your purposes, what I'd probably recommend doing here is once you get those 4 options, plug them all in and see if any of them is valid. Because it's entirely possible that, well, none of them are. And you can save yourself a lot of time and headache and just go on to whatever your next option is. But for the sake of thoroughness, we're not going to be quite so clever. We're actually going to be very stupid about this. And we're going to use synthetic division each of these times to see what goes on. For your own purposes, don't do this. This is inefficient. This is not very smart. What you should do is plug and chug, and if one of them does work, then use synthetic division to identify whether or not just that it works, but what your factorization would look like. Anyway, with this, we have our 4 runs that we can make, and I'm going to go through one of them, and then we'll just show out what the rest are. So we're going to write out those 4 coefficients, 1, 1, -5, -2, and the -2 there because we are going to start with division by x plus 2, where you're going to start by pulling down the 1, multiply that by -2, and you will get -1 with the subtraction. Then you multiply that -1 times -2, get 2, -5 plus 2 is -3. Then you multiply the -3 times -2, you get 6. 6 minus 2 is 4, so we have a remainder there. That tells us that by our results from the last section, it's not one of the roots that we're looking for. So we'll do the same thing a couple more times. We'll do it for -1, where in that case we'll end up with a remainder of 3, as well as doing it for +1, where we'll get a remainder of -5. And then finally, when we do 2, that will give us values of 1, 3, 1, and remainder 0. So don't do it this way. I'm showing you that this is one thing that the book might expect you to do. I'm showing you it because this is the way that, it gets you practice with synthetic division, but I have more interesting ways for you to practice synthetic division than doing something just to do it. You're better served plugging in your values. Once you see that the 2 is the only one that gets you somewhere useful, use that one instead. Just focus on the one that actually helps you, the one that actually gets you where you want to be. And in this case, that would give us the factorization. See, I might have space about here. F of x is equal to x minus 2. It's a really weirdly written 2. My pen's dying. That's great. X minus 2 times x squared plus 3x plus 1. It's only dying on one side. I love it when it does that. And then from there, if we want to get our values, well, we'd have to figure out what the zeros are here. Unfortunately, our best option is the quadratic formula, where I'm going to skip the half step there of using the quadratic formula because we've seen that a few times by now. What we'll end up with is -3 plus or minus root 5 over 2, and that means our roots are the zeros of this thing, the zeros of that thing, which would be 2 and negative plus or minus root 5 over 2. So, to recap, when you're given this type of situation, don't do all of these things. Instead, check first what your possibly useful answers are and just focus on those. It's a better way to use your time. It's more efficient. Math is all about efficiency. I'd rather you do that, but I'm still going to show you this anyway because you should see more examples. I'll put my time into writing that stuff up. You shouldn't put your time into working it out. Anyway, from here, we're going to look at some more things that we can do to identify our roots. We're going to talk about some of the properties that we have with polynomial roots in general.